the next hour or so, we're going to be talking about the development and production of TV test cards. And with me is George Hersee, who for many years has been associated with that subject. We'll be talking about the very first 405 line designs right down to the most modern electronically generated test patterns. But before we do that, George, perhaps you'd like to tell me a little bit about your background. I gather you're retired now.
Yes, I did 30 years in the BBC. I joined them in 1949, having done a few years in industry, and went straight into the development of the first studio the BBC did at Lime Grove, and carried on from there. And it was the outcome of those first 2 or 3 studios that we felt that we needed some more precise ways of measuring the performance of cameras that led to some of the development of test cards which went on in the BBC.
Fine. Okay, well, let's just pause there before we get into that. Let's dispose of some basics, because we ought to define the subject. Test cards can be a number of things, but basically they divide into opacities and transparencies. Those are both technical words. George, what is the difference between a transparency and an opacity?
Well, a transparency is, as its name implies, something which you can see through, and they come usually on sheets of film like this, or in slides on glass plates, and they come in all various sizes of those. And the most common one used in the television industry nowadays, the 2x2 slide.
Oh, yes.
Which, of course, everybody would be familiar with.
Yes. Now, according to my notes, there are 3 ways of actually transferring those patterns onto the screen using just an opacity in front of a camera on a stand,
yes, well,
or a slide scanner, or a monoscope camera. Perhaps you can just tell us the advantages and disadvantages of each of those 3
Well,
methods.
This is the opacity, which, being opaque, you can't see through. You have to use reflected light. You have problems. If I tilt it forward, you might get the gloss sheen comes up, which is a problem. You have to have the lighting around, as in the studio, it's all right, but not always available. It also has the disadvantage that you can't get the same density range on an opacity that you can on a transparency. And for testing of cameras, we have throughout the years been pushing the photographic process to its limits. And we always want the contrast range that you can get from a transparency. So all the most definite and definitive work for accurate testing is done from transparencies in front of a light box. They, of course, take, as I say, various sizes and various shapes. Disadvantages of transparencies, well, mostly handling. They are more delicate, of course. You mustn't get thumbprints or so forth on them. You have to have the light box. But really, that's all. Yeah. The thing is, people should remember, you don't just draw something and photograph it.
No, we're going to be coming.
And it's making that raises the problems later on here.
Yes, I did also mention monoscopes. They're a bit old-fashioned nowadays, but a lot of the early test patterns were produced on monoscopes. This is a monoscope tube, in fact. It is a camera tube, but instead of being an optical tube which looks at a scene, it has a fixed single pattern in it. That's why they call it monoscope. And the pattern is, in fact, printed on a metal plate, which is scanned inside the tube. These were developed in America before the war, and for several years were quite popular, but they were also a maintenance liability, and they're, apart from Russia, I think, and a few stations in America, they're out of favour these days. Anyway, that's enough about monoscopes. Leave them. Now, can we just make a few more definitions, George?
Yes.
A test card or test pattern and a tuning signal, what's the difference?
Well, the test card, and I should say here that whether it's an opacity or a transparency, is by convention always known as a test card. Oh. That is used by mostly engineering for engineering tests on cameras. You are out to test the light conversion from light to electricity, the electronic part. Yeah. Tuning signals, well, they are very simple. They don't really come under test cards. I always exclude them. They were normally produced not by engineering divisions, but by program side. They were just really sort of pretty patterns to identify the station. And in the old days, they were used so that while people's set was tuning up, and they used to have to allow 20 minutes or so for the receiver to warm up and settle down, they had a pattern to look at and know they were getting a picture. But the trade test transmissions are for the viewer to line up, and for the field engineer, the poor engineer from your service man who calls round to see what is wrong with your receiver, to give him a signal that he looks at, that he is consistent with. He knows, because he's been looking at that same signal for many years, and it is designed to show up certain faults and problems that he may have to correct.
Yeah. Okay, well, I suppose most of us would recognize a test pattern if we saw it, but they're more than just a pretty geometric pattern designed to look slightly technical in a TV dealer's window. Who actually designs and specifies these patterns? How does that work out?
Well, the person who actually designs them usually has to take quite a compromise. It depends what it's for, and this is the great thing I always emphasize. If you've got a test card that is designed for one particular purpose, or one set of tests, and nearly does that job for another set, be very careful, because people quite often misinterpret things that are on test card and say, well, I've used that for this purpose and it doesn't show up a fault or something, and you say, well, it shouldn't. Can I sort of take you through one of these, for example?
Please do, yeah.
This is a typical one, originally made by Marconi's, but it is here to show the geometry of the scanning, and for that purpose is divided up into equally spaced grids in both directions. One is out to test any troubles that picture getting into the synchronization period cause, and that's this set up here and here. The eye can quickly detect errors on a circle more than it can on a grid, so they put a big circle in. They were worried about focus in the corners, so you have 4 sets there. One is worried about the grayscale, the reproduction of greys from black to white, so we put several sets of those in for looking. And then we want to measure the fineness of detail, the resolution, and those are put in by various parts here. Now, there are 2 types. This one has bars of equal mark space ratio, black and white, but they only work at one frequency, which is rather good. I've always liked that. You know that you're working at a particular frequency. A lot of people like these so-called wedges, and what you use those by looking at the picture monitor and trying to determine where down the wedge is the last part you can decide. And you can get 2 observers, you can get up to 6, 8 dB difference on there. So no accuracy at all, but that's it.
Can you tell us, George, how they are actually produced? Do you just sit somebody down in front of a drawing board with some graph paper and Indian ink, or is there more to it?
Well, I'm no draftsman, but yes, you could this one, for example. With modern materials that help in drafting aids, you would draw up the whole of the pattern. Where you want these various sets of greys, you can buy tints which you cut out with a knife and stick on. These bars you could either draw, and don't forget, you wouldn't do it this size, you would probably do it 3, 4 feet wide, equally as big, for accuracy. You could, in fact, draw all that and produce it. But most of the modern ones are done by photographic means. Quite often, the grayscales are done by different exposures inside special masked areas, so that you only expose the black and then the next grey, and you adjust the time to get the scale you want, things like that. And you might well end up with something like 10 or 15 masks that are made to cover a pattern such as this or what.
And then you assemble them and take a photograph of the final thing.
That's all done to print down a master negative, and then you reproduce from that. Or on another occasion, I have seen them made 3 feet wide as an opacity on the wall as a negative, and then you just photograph that.
I see, yes. Well, you ought to know, because I understand you have been involved in this sort of work for quite some time. How long, in fact?
Well, as I say, I joined the BBC in '49. It was about 1951, 52 that we started, and we were looking for a test chart to test the old image orthicon cameras, which were just coming into vogue in those days. And we started looking around and saying, we must have this, we must have that, and started writing our own specification for a card which didn't exist up to then, because the old A and B, as we knew them before the war, were too simple for that purpose.
No. And were you always working with the BBC?
Oh, yes.
Yes, I see.
Well, sometimes it was later on it was a joint effort with Bremer and the IBA when they were formed.
Oh, yes, we'll
ITA,
come to
yes.
that. Well, you said you started working there in 49. That was just a year after this picture was taken.
Oh, yes.
Now, that shows the original method, I think, of
Oh, yes.
shooting a test pattern. In this case, it's a tuning signal, but it's the... What sort of camera is that?
That's the old Emitron, which was used in AP up until, well, I suppose about 1954, 55, when they were replaced. And that is looking at a card which is on an opaque board on there, and that in fact is a tuning signal that was radiated for something like half an hour before program started.
Yeah, it looks pretty crude and simple, but obviously effective at that time. Now, you were talking about test cards A and B. I think we might as well get into the swing of the mainstream of British test cards. Can you tell us about A and B?
Well, A was a design brought out before the war, used by EMI at the Alexandra Palace Studios. In those days, it was 405 line scanning, 3 megahertz, as we call it now, 3 megacycles as it's marked on the card, was the upper frequency of the bandwidth. The main interest was at 2.5 megacycles, so that one was put in the middle, there was a circle, and there were 4 other charts. This was a very simple thing in very early days when they were experimenting, finding their way, but it gave quite a lot of service. But it began to be shown that it had deficiencies or didn't have enough precision and enough testing in it, and gradually went on. B was a very similar one, except that where, we don't have a copy of that, by the way, I don't think there's one left in existence, but we have got the pattern of A, and where the A features under the circle, we used to stick an Ilford panchromatic response chart. Now, this was a chart issued by Ilford of some coloured bars, not the ones we're familiar with electronically generated, but just across the spectrum. And it showed against those their grey response on a panchromatic emulsion. And that was stuck on this card and caused no end of confusion for many, many years, because the greys looked rather like a step wedge, tapering away at both ends. And people used to try and refer to the response of the colours as step 1 or step 2, step 4 on this step wedge, but of course it didn't exist and didn't really mean anything. It caused a lot of confusion.
So obviously there was a need for a better test card, and that came along fairly soon. I've got this page here from an April 1948 Wireless World, which I'll show you in a moment. This talks about the new test card C, features and notes on its uses. As far as I can tell reading this test card C was a major breakthrough. How was that?
Oh, it was indeed. A and B were only used internal to the BBC. They weren't radiated at all. If any card was radiated, it was the tuning signal. Oh, yeah. But in 1947, 48, everybody from television who'd been away in the war working on radar came back, and the service reopened. Standards went up enormously because of all the experience gained during the war years. And it was realized that with the viewing public increasing in large numbers, it had gone up from something like 20,000 in 1946 to something like 500,000 in 48, that there were so many more people out servicing and putting sets right in homes that they wanted a signal that they could look at during working hours. And the BBC and Bremer, who are the Radio Equipment Manufacturers Association, got together and produced this new test card C, which would help the man in the field. And this was the first of the properly designed trade test cards.
Well, it's been with us for many years. It still seems to pop up now and again. But having said it was such a breakthrough, I believe it did have some shortcomings all the same.
Well, it had, yes, it did. It was used in many versions. It had a lot of it covered the transition to 625, so there are versions marked up for that. There are versions marked up for transmitter, low power and things. Oh, yeah. But the trouble with it really was the fact that it wasn't made to a specification. Oh. The pattern was drawn up and everybody used that pattern, but there was no specification as to performance, as to densities of the various steps on the step wedge, or as to voltages that they should be when looked at out of a camera. And I remember my early days going out and helping people shoot this, and if you didn't like the look of that step wedge, you just stuck different bits on until you got the answer you liked. And of course, it didn't really help.
That's not very scientific.
It wasn't very scientific and very helpful. And the result was that since it was a different version every time you reproduced it, you couldn't repeat it from day to day. And in those days, of course, it wasn't necessarily centrally generated, so you had every region generating their own. There was a different quality for the trade.
Sounds as if it was a cue for a more scientifically designed test card.
Yes, we tried, then moved on to D, logic progression, of course. We reproduced a lot of the features of C. It was a very good design, and there was a lot to be said for it. It just wanted standardization in a way, which we did. We said that, well, in order to standardize, not only must we write a very strict performance specification for the transparency, but really we ought to go to one firm so that we can guarantee that they are all as near as can be made the same. And the other major change, we went from what were called square waves, and on this panel, if you remember, these are black lines and white lines with sharp edges. Yeah. Well, when you put those through a system which has limited bandwidth, you get errors introduced, and you can get ringing and all sorts of false echoes, which make the reading that you look at, or that you shouldn't really measure these on this card, but when you look at them, you get the wrong result. Oh. So we said, let us make it into sine waves as you scan across, and then we're only generating the one frequency that we are interested in. And we did that on D. It does have the problem that, having been used for many years to getting the response that you see from these rectangular ones, when you get the very much softer response from sine waves, people think their sets have all gone out of focus. Yes. And it does cause a lot of problems, because as well, you get the problem that when you put this through a limited bandwidth system, the amplitude goes up. And that, at those days, used to overload some of the transmitters or parts of the system. So we reduced the amplitude as well as converting it to sine waves. Now, from an engineering point of view, that was extremely good. But it took the trade a long, long time to get used to it, and there was complaints for quite a while about it.
Okay, well, it's clear then that you were involving Bremer. I believe also the ITV were involved on that one as well.
Yes, the ITA had started then, or IBA as it is now, and they were involved with that. There is a rather interesting story, might interest you, about both D and its 625 successor E. Yeah. D was designed and a lot of time spent by an engineering committee who produced a very good design, as they thought, which would have tested very reasonably all the sets that were being produced then and would have helped the field engineer. But Bremer went away and said, well, we'd better go and consult our commercial boys. And they came back and said, oh dear, you're showing up all the parts where we have trouble with present production. So they vetoed it, and we had to start again.
Really? Yeah. I see. Well, you mentioned 625 lines there. Now, 625 line was obviously on the way by that time. Now, according to the Blue Book, which we've got a copy down there, which people may want to read afterwards, in fact, you were involved in that, in the early days of 625 lines, the BBC apparently used modified test card C and also an American SMPTE pattern, but obviously a proper pucker 625 line pattern was required, and you mentioned that was test card E.
Yes.
Are there any other changes in test card E?
Well, we got a little more sophisticated on the sine waves, and fed them into the background grey a lot better. But unfortunately, this again had this effect that if you looked at it visually on a receiver at home, it made the whole thing look rather soft and lacking in contrast.
Yeah.
And so E was put into use, and by the end of the day, the trade had objected so strongly from the field that it was withdrawn, and it had half a day's use. And
That
that
probably
was it.
explains why not many people remember test card E.
No,
According to the reference books, it was used in Portugal and Southern Ireland, but obviously not very much over here.
No.
Hmm. Well, after E comes F, so that was your next project, so to speak. I believe that was more than just you involved on that one. It's a bit of a
Yes.
family affair. Tell us
Well,
a bit more.
again, it was a committee, and I had the honour to chair that one.
Yeah.
It was Bremer, BBC, IBA in those days. And colour was coming along, they said, we want a colour pattern. We didn't quite know what was wanted. We did know things had come out. Obviously, they liked C and D's basic format of the rectangular with the corner sloping bars and the circle.
Yeah.
But we wanted a colour picture. Now, the human eye is most sensitive in colour to large areas of flesh tone.
Yeah.
And it was felt we ought to have a fair amount of that. You can't reproduce flesh tone if you take and make a little rectangle of the same colour on the CIE diagram. It still doesn't look flesh toned. It must be flesh. We wanted certain amounts of red, green and blues and the complementary colours in if we could, rather like a father famous SMPTE photograph of a girl in a hat, which was well known. And so we started and we tried all sorts of pictures and tried to get it, tried to say, well, we had one extra commitment. The technical people said we must have something to indicate approximately the centre of the card, because in colour, if you're checking for convergence, you want to rotate the whole scan about its centre, and you want to be able to say that it is the centre that's the centre of rotation.
Oh, yeah.
So we tried to get something to indicate the dead centre, possibly by a glint in an eye, you know, a specular reflection in an eye, or off a glass. That didn't work. We had a thought, well, could we use an Indian and perhaps have the cast mark? We thought, well, no, that's not the thing to do. That would cause trouble. We tried all sorts of things, and then one day we were sitting down and saying, well, you know, it's difficult. What we want is a cross in the middle. Black on white on black is what we would like. And somebody said, well, why not play noughts and crosses? And that's how we started. So noughts and crosses board, something to fill up the corner with a green colour, because we were a bit short of green. Little girl to be playing and looking at it. So I went home, did a few experiments, and got the daughters to help, and we took some photographs, trying various things. Went back to the committee and said, you know, showed it to them. They said, oh, yes, that's a good idea, we'll do that. So we said, well, we'll hire a model and get something done. And they said, oh, no, don't hire a model, we like that one. And I got two daughters. One hair happened to photograph lighter than the other at that particular time, and they chose the lighter one, Carol. Of course, that was 1966. 1985 now, she looks a little bit different.
I bet she does, yes.
But there we are. So that's how that came about, and then we went off to a professional advertising photographer who is used to being told, that is the picture we want. No, photograph it, or produce it for us, rather than a portrait man. And we had a lot of goes. I think we had about 6 sessions, totaling about 12 hours, all told, before we finally got the transparency that we all liked and nobody could quibble about. And then at the end, the last thing, everybody said, oh, that's quite all right, we approve of that. And then somebody upped and said, oh, but she's using her left hand, so we turned the transparency around.
Really? Now, normally one would expect to find an adult rather than a child on a thing like this. Why did you go for a child?
Well, apart from the mundane fact of reproduction freeze, and of course, we were just after the time when a famous model had done a very long run of advertising for, I think it was the Milk Marketing Board, and found she got no more work because she was too familiar. And so we wouldn't have got professional models of adults. But the adult ladies, bless them, always change their makeup styles every year or every 6 months. Yeah. And we couldn't go changing our picture to keep up to date. No. So, you know, it was a quite obvious thing to go for a child.
Well, I think that is one of the most popular test cards of all time. It's been used in several spoofs in comedy programs on TV. It's been used in the Guinness advertisement with a mug of Guinness in the middle. And it's been seen abroad, of course, because several foreign countries adopted it as well, didn't they?
Yes, F in its standard form, as I refer to it, as used in this country, with just different identification label, as used in some 25, 30 countries. I haven't got the exact figure. But we were also asked eventually, or the firm that made it, and I gave them some help, to produce equivalent versions with a different picture in.
Well, why not mention it now? What did you have to do to it for these foreign markets or export versions?
Well, in general, the one that comes to mind is Singapore, Radio Singapore, where they have some more real ethnic races that they don't wish to offend. And so they produced some transparencies. They sent us about half a dozen for us to pick the best one, of 4 little girls from their 4 major ethnic races in one little group. And it makes a very charming shot. And that picture was replaced in the center. And Malaysia did another one with one little girl looking, and they got rid of the noughts and crosses and put a different pattern in.
Oh, yes.
Singapore, I think, have a mango in the middle, if somebody can identify it.
Very good. Okay, well, let's move on to the next one in our progression, because we've been going through the letters of the alphabet. Next one is letter G, and there's several Gs. I think you said that in the BBC they've been through more than one G, and also quite a few people are familiar with Pi's test card G, which is really just a modified test card C with an extra circle and turned into a 625 line version.
Yes. Well, I used to say in those days, and I still think it's, well, not quite so true now, but in those days, the number of test cards sculling around the industry was probably comparable with the number of engineers.
Yeah.
All the supplying companies had their own set of various cards for various purposes, which they would sell you. Some identified them like Marconi's with numbers, some like Pi's with letters. Certain people in the BBC and the IBA doing experimental work themselves just gave another letter and took the next one of their own choice, so that one engineer I know went up to sort of L and M, but they were never transmitted. In fact, half of them were never made. They were drawn by a draftsman, and that was the end of it, you see.
Yes.
So when we came down, the only G's which really came any good were the particular one you referred to with Pi's, which was a version of C with a large circle superimposed, and that one was quite a popular one. And to keep in the progression of the trade test cards, G is the one given to the all-electronics one generated by the Philips machine.
Well, George, you're a BBC man, so as far as you're concerned, test card G is the main electronic colour test signal of today. What was your involvement with test card G?
Well, I was sent to the Philips factory in Copenhagen, where the machine was designed, because we wanted 2 special versions for the the English market. It may sound a bit peculiar, but for reasons best known to themselves, the BBC used what are termed 100% colour bars, and the IBA, or ITA, adopted the EBU standard sets of bars. Now, the difference between these was really that the EBU bars were designed to give a good representation over a lot of the poor circuits that the EBU had at that time, whereas the BBC ones were designed to fit over and to test how good some of the circuits were. And because of that difference, there were 2 standards available. There were 2 different amplitudes of the signal and 2 different bottom levels to the black, the equivalents that we had to put on. So we had to go and negotiate with the Philips designers and say we want 2 versions of this. And that's what we did.
I see. Well, somehow I don't find test card G as satisfying visually as Carol in test card F.
No.
I think the BBC must have recognised this because they've reintroduced test card F in a digitally stored form, which looks very good. I wonder why they gave up using F in the first place.
Well, I think it's a question of now, of course, it's time. They don't radiate test cards very much.
No.
Like we talked to an American once, and he said, oh, trade test cards, what are those? We don't have them, you see. We sort of explained when they were radiated. He said, well, the only time we have is between the end of the Late Late Show and the first of the breakfast show, between 5 and 5:30 in the morning, you know.
Really? Yes. And I suppose an electronic test signal is far more controllable and reproducible than colour slides.
Oh, yes, it's a lot easier. I mean, it's just a black box that sits in the bay, and you switch it on, and out comes the signal you want. There's no lining up any optics or anything.
No. Well, OK, so far we've been talking about trade test patterns because these are the ones people are familiar with, the ones that they may see on their TV sets at home. Let's move on then to the engineering test patterns, which we don't normally get to see. Perhaps you can just tell us a bit more about those.
Well, there are a whole series of those, of course, and they range from some very simple ones, which are just used for in testing cameras very simply. But back in the mid-50s, we decided that we needed a series purely for testing cameras.
Yeah.
And there weren't many available that were suitable. We decided that because of all this confusion of so many numbers and letters that have been used, we'd start much further on. I said, well, let's start with 50. Nobody got that far. So the first one we made was a test card 50. I don't think there's one extant now. It consisted of 3 primary colours, red, green and blue, as transparencies, made in gelatine, and into the centre of each one we slipped a piece of Kodak test step wedge, so that you could tell the reproduced level of that colour by just comparing it with a step wedge. That was made up, all individually handmade, quite expensive of course.
I bet.
Yeah, 12 by 10 glass slides. I haven't seen one for a long, long time.
No. I noticed this has a number rather than a letter. Is there some significance in that?
Well, we thought we'd keep the engineering test ones away from the trade test ones. They were 2 entirely separate purposes, and it's better to treat the 2 as the same.
Yes.
There was a little confusion at one time when somebody who was sort of in charge of looking after that and decided to give D, E and F some of the numbers out of the 50 series, but that's just to add extra confusion, which we try to avoid. But the next one on, of course, would be 51.
Well, we're just about to come to that. Yes, so we've got number 51 up on the screen at the moment. It seems to show a happy-looking couple down by the riverside.
Yeah.
What story would they tell if they could speak?
I don't know, really, but interesting. That, of course, wasn't a picture that we commissioned. We went to Ilford's and went through an awful lot of their advertising photographs, which, of course, were very high quality. And we were looking for a picture which would help anybody who was not technically minded or wasn't an expert in the subject to get a fair idea of the performance of camera by looking at that picture. We needed a picture because the image orthicon of those days was not happy looking at a blank grey screen, and we wanted something that we also had to find a picture which not only looked pleasant and gave these aspects, but also when we slipped the step wedge and the bars in the middle wasn't going to be sort of really badly mutilated.
Oh, yeah.
So we went through quite a lot for those. The funny thing about that was Ilford said, yes, that's quite all right. You may have the use of it, providing you never radiate it, or only on, occasional minutes. And a certain firm out in Europe went and bought a copy and radiated every morning, so there was a great row went on about that.
I see. Well,
but that was the 405 version.
Yeah.
And then we eventually made the 625 version with 52. And the story between the difference is how they were made. I think that might interest people.
Yeah.
We were trying again sine waves and how to make them. And for 51, we took a camera and we put an oscillator onto the screen and got a sine wave on the picture wave, and we photographed it. And we tried to adjust the sizes by taking the camera further away and so on and so forth. Well, that meant that we ended up with fairly reasonable amplitudes, but the frequencies were a little bit out. And in fact, what is labelled 3 megahertz on test card 51 is in fact nearer 2.6.
Really?
So
Yeah.
they got a bit. For 52, the 625 version, we got a little better because our colleagues had got on with the film telerecording cameras. And we said we can use those and take a large section, a whole frame of 35 mm, let that into our 12 by 10 slide, and we can get the frequencies right that way. But unfortunately, with that system, it let us down because the oscillators in those days didn't run stable enough, and their amplitude varied over the picture frame at the very slow speeds we were going. So although the frequencies are accurate on 52, the amplitudes vary.
Really? Oh.
So in fact 51 is still the one that's in use even on 625 lines.
Really? Well, the next picture doesn't suffer from those defects because it's a hand-drawn early colour test pattern. Any idea when this one dates from?
I guess that must go back to around 1960, 62 or so.
Mm-hmm.
This one was made by the experimental unit who had, I think it was 3 RCA 3-image orthicon cameras.
Oh, yeah.
They were huge, massive things, used in Studio H at Lime Grove as an experimental basis, doing a lot of experimental colour work and learning about it. Not producing programs as such, a certain amount just to learn program techniques, and that was all. And this was something they knocked up themselves for their own use.
I see. Jolly good. Okay, at the beginning of this program we briefly touched on tuning signals, which are for the less technical people among us, supposedly for setting up our TV sets. Nowadays, when we switch on the colour television, we expect it to come on, and of course it does. Absolutely perfect. But if you read the guides to television of the 1950s, they go into great length about, as you said, switching on the television set 20 minutes before you intended to start viewing and adjusting all the contrast controls and that sort of thing. Anyway, we've got a couple of them on the screen. Now, the first one I see is the BBC Angel's Wing pattern. The next one is the first design used by the ITA, which was a form of simplified test card C. And finally, we've got the second later pattern used by ITV transmitters before the start of programs.
Of course, there were a whole series of those for each transmitter. As they put them up, they wanted a radiation pattern just to put out.
And now we've got a couple of more specialised tuning signals, one for schools television, and the rather unusual one used during the pilot transmissions for Band 3. This special pattern showed up ghost images caused by multipath reception and allowed you to calculate the distance of the obstacle causing this problem. Caption slides are also used for the so-called apology messages and other service information, such as when a transmitter is on reduced power. These may be inserted at the studio centre, or they may be originated at the transmitter. Here's one saying reduced power, and another one explaining difficulties with the picture outside the BBC's control. And this is the first ever TV commercial in Britain, transmitted by Belling and Lee, who had a mobile transmitter in a caravan at the Croydon site in July 1955. Finally, to add some variety, here are some proprietary and foreign test cards. They all show, in fact, that most test patterns follow the same basic principles, and they'll also illustrate some other points as well. First of all are two of Marconi's own resolution charts, as they call them. This is number 1, used widely inside the Marconi company and outside. It was often customized with an insert of the client's name. The second one is a pretty picture used for subjective assessment of TV receiver performance. Many TV factories in fact had their own test transmitter coupled into an internal cable TV system, and the newly made sets were tried out on this.
Again, using pictures to break up the backgrounds of image orthicons, because they just wouldn't stand a plain background.
Now, this is an example used across the water in Ireland before they went for colour.
RTE, yes.
And from Germany, we have the TO5 pattern, very widely used there at one time.
But that, of course, has got mostly wedges for measuring the resolution. I've never liked those at all.
And now over to the States. And this is the famous Indian head pattern devised by RCA, originally used on monoscope tubes, but this example is from a slide. On this one, it's interesting to note how the grayscale is not a true grayscale, but more shades of grey made up by thin lines intended to be inadequately resolved, as they say, by the TV receiver. A major weakness of this particular design is the large area of white background, giving a high duty cycle, which the transmitter didn't like. An average grey background would have been better. Finally, a couple of the so-called bullseye patterns, and these ones are in colour. In a way, you could say they're more of a tuning signal, or combined tuning signal and test pattern, and nowadays these are being edged out by electronic colour bar patterns. Just picking up a point there, George, was this sort of idea of sort of fine black lines ever used in this country rather than sort of grey scales?
Yes, yes. Not for anything used by the broadcast people, but in the early days of closed-circuit television, they wanted an opacity, this sort of thing, with to be done very, very cheaply, something like you could throw away at a loss, and it was done by printing by normal screen techniques, using a very fine printer screen.
Well,
so then you weren't worried about the grayscale at all. It was purely you were printing black and white, and that was all. And it worked very effectively.
Yes, well,
limited, of course, the amount of black density you get in the blacks. That was the trouble.
I see.
But that was quite effective. Just one more thing I'd like to bring up. So far, we've been talking of engineering test patterns as a pattern. In general, when we're trying to look at transitions from usually from black to white or one colour to another. But I think we ought to point out that we've only been discussing one or two patterns. There are a lot of others for various special purposes. For example, there were a complementary pair for lying two projectors together so that they fitted in the missing parts. And this one, which I have here, which was purely a girl's head, but it was used for the final colour rendering check on a camera. Now, in the early days of colour, the BBC used to hire models who would come in for half an hour before start of every programme, and they would sit down, as we are here, and all the cameras would look at them, and they would adjust the last titivation of the colour rendering on these model skin tones. And of course, this was very expensive. And we said, well, we can't reproduce that. People tried using a model skull and wigs, and of course that was expensive because wigs, to have them cleaned every fortnight, were very expensive.
Oh, yeah.
And eventually it was thrown at us to try and produce a photograph that would do it. And we did succeed, and it was very interesting to say that early on we were saying you just photographed something and reproduced it. Jeremy Royal, who makes this particular test card, it's only available in this country as an opacity, uses 8 different pigments to go down and then a tint in the final varnish. But the research department sent it off for analysis, spectral analysis, and compared it with typical skin tones of Eurasian women, of European women. And it's very, very similar, and there's a steep jump in the curve, the spectral response of skin tones, and this reproduces it.
Well, thank you very much for coming along and telling us all about that, George. Any final points?
No, not really. It's only to say that, of course, in an hour we can only talk of a very, very few of the thousands of various designs that have existed and been produced over the years.
Well, thanks very much for coming along. I found that fascinating. I hope everybody else does too.
Right.